In this video, we will discuss about how to perform point biserial correlation in SPSS. Before that, let us quickly understand what point biserial correlation means. So, point biserial correlation is a special case of Pearson correlation, which examines the relationship between a metric variable that is measured either on interval or ratio scale and a dichotomous variable. Now, what is a dichotomous variable? So a dichotomous variable is one which can only take one of the two possible values. Hence, it can also be termed as a binary variable. Generally, a dichotomous variable is categorized into two. First being naturally dichotomous, where the variables are naturally divided into two distinct categories. For example, if we toss a coin, we will either get a head or a tail, no other option. And in case of gender, we are having two genders, male or female. The other category being artificially dichotomous means where the classification is made on basis of some criteria. For example, we have decided that the students scoring above 45% marks to be declared pass, and the ones who score below 45% will be declared fail. Now, this percentage could be changed. Thus, these are artificial dichotomous. Now, an important point to be noted here is that in case of natural dichotomy, point biserial correlation is used. Whereas, when dealing with artificial dichotomy, it is advisable to use biserial correlation. Moving ahead, if we were to calculate point biserial correlation coefficient manually, we can use this formula right here. Here, RPB is for point biserial correlation coefficient, and this is the formula. Now, since we are here to understand how to perform this on SPSS, we will be quickly moving on to SPSS 2. Here we have a data set where you can see the test scores of students on metric scale and the other being dichotomous variable, that is gender. Now to calculate the point biserial correlation coefficient, we simply click on analyze. From there, go on correlate. Under that, we click on bivariate. This dialog box appears. We have to simply shift this in the variable table. No need to make any changes over here as these are default settings where correlation coefficient already the boxes are checked. Moreover, we can go on options to check on these boxes if we want, means and standard deviations. And we click on continue and then OK. So the output for the same is generated here. Here we have the descriptive stats. And here below, we have the correlation table. Focusing on the p-value, that is 0.211, which is greater than 0.05. Thus, we fail to reject the null hypothesis. And in case of correlation, we know null hypothesis means no correlation. It is used when we are going for a hypothesis testing. But if we have to simply see for the correlation coefficient value, then it is 0.343, which is positive, which indicates a positive association between the two. This was all for the video. Thank you.